Alright fellas, today we're looking at two-way tables, and they go nicely together with probability and our Venn diagrams that we've discussed as well. So we've got two-way tables. Now I've put a basic general example up here. Now what you'll see is we've got a test result and a disease present. Now all this is saying is this is a way of representing some information for two different criteria. So obviously up here what has happened is, let's say someone's had a blood test for diabetes. Now this up here, the test result, well, can either be positive or negative. So the blood test can either say yes you have the disease or no you do not have the disease. Now what in reality, we hope that a blood test like that is very, very accurate, but what we want is to know who actually has the disease and who doesn't. So that's what this tells us. So disease present tells us whether that is true, yes they have the disease, or no they do not. Now obviously see, as we look at these two colours here, the people along this axis, they're correctly diagnosed. They've either been told yes you have the disease and they actually do, or no you do not have the disease and they in fact don't. The people on this axis, however, they've been wrongly told. So they've been told, well, yes, you have the disease, but no, in fact, they don't. Or, no, you're fine, you don't have the disease, but the blood test has been inaccurate. So people going from left to right here are inaccurately told. People going the other way, and as indicated by these colours here, they've been told correctly. So it's a way of representing information here. Now we could do it much like our Venn diagram with some information about what sport someone plays, or whether they're a board or a day boy, or compare your height and something else, which is the example we're going to look at in a second. But this is a common one as well, about a test result being positive or negative, and whether in fact it should be positive or negative. So what we call is the bottom left here is a false positive, and the bottom top right here is a false negative. Okay, let's have a look at an example. Okay, Nathan surveyed 150 boys at his school to determine whether a person's height is a factor in playing AFL. Well, straight away, my table I'm going to go and draw, and it's going to have 9 cells. 3 across and 3 down. Now, well, it's a two-way table, yes, but in fact what we need, and in fact I'm going to draw that again very quickly and you'll see why. Because we need some totals here, we actually need a few extras. And you'll see why. You'll see why. Okay, so right down the very bottom here, I'm going to go and say that that number is going to be 150. Okay, and because we know that all the boys in the E group are 150. So 110, so let's make this one here. We're going to make that the height, and this is going to be whether they play AFL. So what are the height divisions? The height divisions are 175 centimetres, 175 centimetres or shorter. So actually 175 centimetres or taller. So the height is going to be less than 175. Or greater than or equal to 175. Well, we know in total 110 of those, and that's a total. Those 110 boys, before we find out about these 38 here, and we'll get to those in a second, before we find out about those 38, we just know there's 110 boys who are shorter than 175. That means we're going to have 40 who are taller than 75. Now let's go and have a look at this. Well, let's say whether they play AFL, yes or no. And that's just whether they play AFL or not. Well, we know 38 of these boys, these ones here, played AFL. So if we go work that out, that means there's 72 who were shorter and didn't play AFL. Okay, so everyone here fits into two categories. You're either tall and you play AFL, you're either short and you play AFL, you're short and don't play, or you're tall and don't play. And everything obviously has to add up to 150. Let's go have a look at the next part. 40 boys had a height greater than 175 centimetres, and 22 of those boys... Okay, so, sorry, I've drawn that in the wrong one. 22 of those 40, these 40 here, played AFL. That means 18 didn't. Now let's go work it out. What we end up with is 60 who play and 90 who do not. Okay, I hope we're happy with that. Let's have a look at some of the questions. That's just part A. You'll see part B on the next slide. Okay. What is the fraction of boys who have not played AFL? Okay, well, let's go back and have a look. Well, I think for part B there, I think we found 90 boys out of 150 did not play AFL. Okay, so that's going to work down to, what's that, 9 over 15. Take out 3 as the common factor. 3/5. 3/5 do not play AFL. And that means 2/5 play AFL. What percentage of boys whose height is less than 175 have played AFL? Alright, well, let's have a look at this. What percentage of boys whose height is less than 175 have played AFL? Well, this one actually, what we're referring to is what percentage of boys whose height is less than 175. What we're referring to there is actually only out of the 110 students. And that's 38 out of 110. Now, that's not an easy one to calculate a percentage for, but if we put that into our calculator, we'd get an answer. And what we'd get is 34.55%. Now it says the nearest percent, so I'm going to call that 35%. And of course, because that 5 is bigger, we round up. Let's have a look at the next part, part D there. Okay, what does D tell me? What is the probability of selecting a boy whose height is less than 175? Well, again, let's go back and have a look. There are the probability of height less than 175. Well, I think we had 110 boys who are in that category out of 150, which is 11 over 15. Again, there I'm only referring to height. I'm not interested in whether they play AFL or not. Let's have a go at E, and I might leave part F for you to have a go at yourselves. Okay, let's see. What is the probability that a boy selected at random? Now, at random just means that we're not going to line them up in height order or anything. I write their names on a piece of paper and then draw them out of a hat randomly. I have no bias in who I'm selecting. I will have played AFL and has a height greater than 175. Well, now I'm actually looking for 2 criteria, aren't I? They have played AFL, so I want the yes category and I want the tall category. That's out of everyone as well. So I want probability of AFL plus greater than 175 centimetres. Well, what's that going to be? How many boys played AFL and were... Well, I had 22 out of 150, which I believe ends up being 11 over 75. And that's fine, we don't need to get that one down anymore. I'm running out of space here, but let's talk about part F. One person was selected at random from the boys who played AFL. Again, I'm only interested in the boys now who played AFL. So that's 60 students who played AFL. What is the probability that this boy has a height greater than 175? Well, we already decided that we're only interested in the 60 boys who played AFL, and 22 of them were taller, so I'm going to say it's 22 out of 60. Or ends up being 11 out of 30. And what you'd do, if we went back and looked at this table, is that I think we'd find the boys who are taller typically have a greater probability of playing AFL. And if you think about it, that just kind of makes sense. There are obviously shorter people who play AFL, but being a sport where you need to jump and get high in the air, if you're taller, you're probably more likely to be good at it and therefore probably try to play it. So can we please copy this example into our theory books, and we'll go from there. Thanks, man.